Hi everyone. Today I'm going to talk about section 3.3, application of the derivative in optimization. And this session, in order to solve all the problem in optimization, you should follow the 5-step strategies for solving optimization problems. As under here. The first step is you may have to draw a figure if needed. So some problems that you may don't have to, but usually some problems with like geometry and something like that, then you should draw a figure better. The second step is you want to try to assign a variable to each quantity. And the third one is you want to select the quantity that you want to optimize and construct a function that relate it to some or all of the other quantities. The fourth step is you want to use the information contained in the problem to eliminate the variables until you have a function of only one variable. Okay. And the last one is you're going to use the differentiation to find the critical value of the function and apply the test for absolute extrema. And you should disregard all the answers that are not relevant to the situation or that are not in the domain of the function. Okay, so let's do example 1 in here. A rectangular region along the bank of a straight section of a river is to enclose with 80 feet of fencing. Only 3 sides need to be fenced, since the river will bound the other side. What are the dimensions that will produce the greatest enclosed area? So this problem clearly is going to be related with geometry stuff. So for the first step, draw a figure. You will have to do it. So I will construct a figure, and you're going to see under here I did construct it. I have all the air. I mean the fence, right? Let's see. The fence with 80 feet of fence. I'm having a close with 80 feet of fencing. So what does that mean? You may gonna think, oh, this side and this side and this side are gonna be 80 feet, right? And you need to use only 3 sides because why? Because the last side, the side, the one over here is a river, so you don't have to worry. You don't want to use any fence for that. And then now after I finish graph a figure, draw a figure, I'm gonna assign a variable to each quantity. Okay, so let's follow step 2 here. Okay, so in here I have this is an area like a rectangular, right? So I'm gonna say let W equals width. How can I spell the width? The rectangular, and I'm gonna let L equal to and the length of the rectangular. And what else? You may want to think about the select the quantity that's optimized, and in here, since it's talking about the area, right? Area. They want to have area, okay? Area. Rectangular.
Hello. Dạ, cho chị mời.
Okay, and because it is a rectangular, let me see, and then you will select the quantity that is to be optimized and construct a function that relates it to sum of all the other quantities. You know what? For polynomial, so I have yes, so I have done with step 2. Now I will move to step 3. Right. And step 3. It says select the quantity that is to be optimized and construct a function that relates it to some or all of the other quantities. Because the question is talking about what are the dimensions that we will produce the greatest enclosed area. So the thing that's to be optimized gonna be area, right? So area. And I think this should be in 3, but yes. So A area is the area of the rectangular, and I'm gonna construct the function that relate it to some of all of the other. So you need to know that the area of this rectangle rectangular has to be equal to the what the width times the length, right? Or the length times the width. So A equal to length times width. I have to insert multiple. Width. Okay. And then what else? Now I gotta move to the number 4 here. And step number 4 say, use the information contained in the problem to eliminate the variable until you have a function of only one variable. Okay. The thing in here is I want function A here to be only one variable, and I am having right now is 2 variable. So what I have to do is I have to use information contained in the problem. What is information that's contained in the problem? It is this 80 feet with only 3 sides. What does that mean? I have, according to my figure, I have this one width plus this length and plus another width is gonna be equal to what? 2 width plus length equal to 80 feet, right? So I'm gonna have ID here, ID fit here, and I'm gonna just simplify it, and it look like 2 width plus 1 length equal to 80. And I because I in the step 4 here, so I'm gonna write down 2 width plus 1 length equal to 80, right? So so I have say information in the column. Is 2 width plus 1 length equals to 80. And you're gonna say, oh, you're gonna have eliminate one variable, or eliminate the variable until you have only one variable. So that means what? Because you are having the function right now having 2 variables, and you have to eliminate one. So either you're gonna eliminate W, or you're gonna eliminate the L. Okay, you have to eliminate one of them. So in order to do that, you have to use the information from this function. Okay, so and what I do is you're gonna choose either L or W. So I gonna choose L to eliminate in here. So since I choose L, then I wanna know what L equal to what L. I want to solve L in terms of W. So I have L. I gonna subtract 2W for both hand side of this equation, and then I have L equal to 80 minus 2W. Okay, and I'm gonna use this to substitute into the function that that relate to all other quantities. So I'm gonna copy this down. Okay, and let's see if it is step 5. Okay, so still step 4. Okay, now I have to change this. I'm gonna substitute the L. Okay, this L. So I have A equal to currency, which is L in here, and multiplied by W. And simplify it, or I'm gonna do distribution. No, actually, you know what? I don't wanna do. No, I have to. I have do distribution for that, and then 80 W's minus 2W's squared. And that is for function of A, and I'm gonna write as A in term of W equal to this. Okay. So now I have derived the function in terms of only one variable. Okay, only one variable, which is W. And now what should I do is I'm gonna go back to the I'm gonna go back to step strategy here, and I'm gonna copy down step number 5. So this is step number 5. And step number 5 says use a differentiation to find the critical value of the function and apply the test for absolute extrema. Okay, so what does that mean? You have to take derivative of AW. Okay, So you actually, because you are looking for the maximum of AW, so you have to take the with that. Similar with some previous problem, you know that. And now you take the with that, you're gonna have 80 minus 2 times 2. You put out 2, right? 4W. And you're gonna set a W to be equal to 0. No, I mean A prime. And you will have what? 80 minus 4W equal to 0. And what do you have? Now you will have what? You will have W equal to 80 divided by 4. So that give me 20. Okay, so it should be 20 feet or inch. Let me see. It is feet, right? Yeah. And since you have W, I'm gonna put down this W is 20. And the question in here is what dimension? That means you also have to find the length. So the length equal to, okay, you have to go back with the information, the function that, the equation that give you the information for the problem, that L equal to 80 minus 2W. And if substitute W is 20, you're going to have 80 minus 2, so 20. Width equal to 40 feet. And that should be the answer for L. Okay. So I'm gonna make a conclusion or interpret this one is I'm gonna say like okay, I'm gonna copy the question down. If we have the length, no, the width is 20 feet and the length is 40 feet, then it will produce the greatest enclosed area A. And I may gonna find, if I want, I can find out what is a area gonna be. So equal to 40 times 20, which equal to, so I'm gonna say area max equal to 800 square feet. Okay. So we done example 1, and I'm gonna just make this stuff. Now, let's move to example 2 here. So example 2 say Sally owns an online business and want to know how to price her inventory 3 terabyte hard drives in order to maximize the profit she makes from their cell. Currently, Sally sells 20 hard drives a week for $400 each. So we cost the store $200 each. She estimate that each $10 reduction in price, she can sell 2 more drives each week. So we're gonna find the price of each drive that will produce the maximum profit for her business. So let me copy down 5 steps so to remind you guys, right? Okay. And you see that this problem is not related with geometry stuff, so I don't think that I need to draw a figure in here. Don't need, right? And now I can move to, so I'm gonna move right away to number 2, step number 2 here, to assign a variable to each quantity. Okay, so hi everyone. So I come back with session 3.3 part 2 because last time I got disconnected with my Wi-Fi, so I have to redo this recording. So in example 2 here, for step number 1, in order to draw a figure, because in here this is not a geometry problem, so I don't need to draw a figure in this case, and I will just go ahead and move to number 2 in here. And because in here we are looking for the price of each drive that will produce a maximum profit for her business. So I would like to assign the price for each drive is P. Okay, so the price is of each drive after reduction is P. Okay, and then because in here it say like she estimate that for each $10 reduction in price, she can sell 2 more drives each week. So so you may think about like the number of reductions in price, and so I will assign R as the number reduction, number of $10 reduction in price. Okay. Okay. And then you have to think about like how many hard drives is sold for this case, right? So I'm gonna say N equal to the number of hard drives she's sold, right? Okay. And anything else? So I may have to say that because in here it says like Sally sell 20 hard drive a week for $400 each. So I need to say some more word in here. Say and the number of hard drive. So after say after reduction, or yeah. or after reduction. After having the after reduction. Okay, so now you have to think about like with this number of hard drives. So after reduction, what's the revenue that you're gonna have? Okay, so I'm gonna say R is the revenue produced by all sale of N hard drives, right? Okay, so what else? You should also think about the cost, the cost of the hard drive in here. I mean, so you because it's a business, so you can see that in order to get the revenues, you need to have the cost for the store here for each drive. So you have to assign C at the cost to the store for N hard drive, right? Okay. And lastly, I'm gonna say capital P at profit with N hard drive or profit realized with N hard drive by the sale of N hard drive, right? Okay, so remember that this big P is different with this P small. Okay, I can say this capital P and this capital P is profit and the small p here is price. Okay, so now I have finished step 2, which is assign a variable for to each quantity in here. All of this quantity is a thing that's changing in this column, so I have to assign all of them, right? Okay. Okay, now I'm gonna move to step number 3 here. Step number 3 here is saying that select the quantity that is to be optimized and construct a function that relates it to some or all of the other quantities. So let's see, in here, I want a weak quantity that I want to optimize. So look at the last sentence. I say I want to maximize the profit. So I need to have a function of profit, right? You need to know that the profit equal to what? Equal to the revenue minus for the cost, right? So I can write as P equal to R minus C, right? And this is a function for profit that respect to R and C. And also I need to notice that the revenue equal to what? Revenue should be equal to the price of the price of each item, each hard drive in here. Okay, each hard drive. So I'm gonna have price here and multiply with multiply with the number of items, right? So number of hard drive. So that is so then I'm gonna write as a R will be equal to P Tom N. So I'm gonna let's see. I'm gonna put insert here, and then with the symbol right here. Okay. So P Tom N is here, and then lastly I need to consider about a function of C, of cost. And you should know that the cost the cost of the store of N hard drive have to be equal to the cost of each item multiplied with, I will have parentheses here, each hard drive multiplied with number of hard drive that she have purchased or she have bought, right? Number of hard drive bought or sold has to be the same. So yeah, I just gonna say like it should be like N later, right? So C and equal to the cost of each hard drive. You may have to move up here to see that's the cost to the store is for the each hard drive is 200 here. So you're gonna go down here and say, okay, 200 times N. So insert, or I'm gonna copy this one. Okay. Oh, actually, why I have to time? That's just change the N. That's same thing. Okay. So, oh, wait. It should be 200. Sorry, 200 times N. Yeah, $200 for each. So N is the number of drive that we bought. Okay, now I have finished construct actually I'm gonna substitute R and C here to the P, so I can have the function that the quantity that is optimized is to be optimized and construct a function, and with that relate it to all the other ones. So I will substitute R and C into here, right? So P equal to R minus C, and I'm gonna substitute R equal to P times N. I'm gonna copy this one. Multiplied by, no, minus, sorry. C is 200 N. Okay. So in short, I have P equal to Pn minus 200 N. Okay. Maybe I'm gonna mark this one with this one, and mark this one with this color, this color. Okay, so this one here, here. This one and color. Okay. So now I have done setting up a function that relates with the optimized quantities. So, but the thing in here is I am having two variable in this function. So let me label this. Okay. So now I'm gonna move to step number 4. I'm gonna use the information contained in the problem to eliminate the variable until I have a function of only one variable. Okay, so what does that mean? I want to find like a function that that have a relationship between P and N, right? Between the price and the number of hard drive. Okay, so let's see. So let's go up here. You say that for each $10 reduction in price, you can sell 2 more drive each week. Okay, so the price was 400 each. Yeah, right. The price was the 400 each here. So say the price here, and the other thing is number, right? So at first it was 400, right? And it's and what happened? If it's subtract, if she have like $10 reduction, so what does it mean? So if she have like 1 minus $10 here, so she have what? $3.90 for the new price here. For the number, so you're gonna sell 20 hard drive if with the 400. If she subtract $10 to have $3.90 for each, then she gonna add 2 more drive for each week. So that means it's gonna be 22, right? So add 2 for this. So it keep doing like that. So right. So minus 10, you're gonna have 380, and then 24, right? It's keep doing that. So the thing in here is in order to get maximum profit, let's say it's keep reducing, like how many time minus 10. Let's say like our time number of 10 reduction in price. So so you will have the price is P that can make maximum the profit, and say at that time you also like adding R times of the number that you will have, which is N here. So so in short, I'm gonna say P should be equal to 400, right? And you will minus for the number of $10 reduction, right? Which is I mean it means R, right? And multiply with the price for each reduction, which is $10. So 10R. So 10R, right? You see that? And for N, you will have like the original number was 20, and you add with like how many times you reduction in the price, we're gonna be the same the number of time you adding two items for selling. Okay, so you're gonna have adding two times R in here. Okay, so this gonna give you the information from the given. So I'm gonna rewrite up down here. So it's a price P equal to 400 minus 10 R, and then you also want to have number of item of hard drive, number of hard drive, which is n, and equal to 20 plus 2R. So so in this case, I will have like substitute these two into the profit to get only one variable. All right. So so I'm gonna say substitute. So substitute P equal to 400 minus 10R and N equal to 20 plus 2R into P, the profit, equal to Pn minus 200N. We have, we're gonna have P equal to, so P now, small p now become 400 minus 10R, right? And N now is 20 plus 2R, right? And minus for 200, N. See that? So, yes, maybe I have to label. So I know that P is here. So P here, and then N, another color. N here. So I have N here, N here, right? N here. Oh, I should also change this N, right? And it should be 20 plus 2R. Okay, and I'm gonna label this, right? So see that? So now I will have, maybe I have to do distribution for this. First one gonna be 400 times 20, gonna be 8,000. And then the minus for no, plus for 800 R, and then minus for 200 R, and then minus for 10 R squared. And then now I'm minus for 200, no, 4,000 plus with 400. No, not plus, minus. So see the, don't forget the magnitude here. Oops. So this one, I want to do distribution for this, right? So minus 200 times 2r going to be negative 400r. Okay. Combine that term. I will have what? P going to be equal to negative 20r square. And then minus for 1200 r. No, not 1200 r. It should be minus 6 gonna be 200 r. And then plus with 8,000. Okay. Actually 4,000 because of this and this, right? So 4,000. Okay, so I have the function of profit with respect to R. With only one variable is R in here, right? So now, because we are trying to have optimized or maximum profit, so we need to take the derivative of P respect to R, right? So I'm gonna say P derivative with respect to R will be equal to negative 40 R. You put down 2, right? And minus 200. And you have to set it equal to 0 because you're looking for the critical value. 0. So then negative 40 minus 200 here equal to 0. Which means what? Which means R has to equal to 200 divided by negative 40. Did I make some mistake here? Let me see. Oh, yes. I make a mistake here. It should be plus. Oh, no. Minus 200. So then here is plus. Yeah. Plus 200. Then you have plus 200 here. And then you have R has to be negative 200. This will be plus. Okay. Minus 200 here over negative 40. We're going to have what? 5. Right. Oh, I'm going to put down here equal to 5. Okay. So the R in here is a reduction of $10. Okay. But the number of reduction. But what we are looking for, we are looking for the price of each drug that will produce the maximum profit. So even though we have R in here equal to 5, but I need to know what is the price. So I have to go back with the price here, the equation of price that I respect to R. And I say the price P equals to 400 minus 10R will be equal to 400 minus 10 times 5, which is 50, right? So now it's going to be equal to 400 minus 50 is 350, and I say $350 for each item. Gonna be the answer. Okay, so I'm gonna say my conclusion is the price of each okay, let me write that, copy down this one and then put that here. So the price of the price of each slide has to be 350 that will produce the maximum profit. Okay, and I'm done for this part. I'm not sure if there's anything else. Okay, yeah, that is the answer. There's some problem that they need you to provide the maximum profit also. So you can just like substitute substitute R into the function of P. So then you're gonna have the function of profit. Then you're gonna have the maximum profit. Okay, so now I will move to example 3 here. Okay, and I will copy down 5 steps so I don't wanna forget it. Okay, all right. So now here's my 5 step. Example 3, a rectangular box. Okay, with an open top is to be made from a 10-inch by 16-inch pieces of cardboard by removing small square of equal size from corner and folding up the remaining flaps. What should be the size of the square cut from the corner so that the box will have the largest possible volume? Okay, so this totally is like a geometry problem. And so I need to draw a figure of that, right? Okay, let me move this down. And I'm gonna say rectangular box. Okay. Okay. So we want to have like a piece of made from 10-inch by 16-inch piece of cardboard. Okay, so you should have like this one, 10 by 16. So I would say here is this one is 10 and this one is 16. So what's they want? What do they want us to do? So they want us to removing small square of equal size. Okay, so they want to say when removing this square, 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 right? All these square are equal size. Okay. Okay. So say, all right. So that is I think that is a thing we need to draw. Okay. And now I'm gonna assign a variable to each quantity. Okay. So what they want us to do? So the question is, what should be the size of the square, right? Cut from the corner. So that means like it's I mean they want us to find the dimension here of the square, right? We need to know
say x for I mean for each side of the square, or yeah, I can say it is x, right? Okay, so we say x. Oh wait, I will move to problem. I will move to step 2 here. Let's say x. X is the length of the side of the square that is cut from the flat piece of cardboard, right? So say x here, okay. What else? Maybe I have to draw how the box look like after you folding it, right? So say folding and folding it. So if I fold it, it should look like this. Let's see. Like this. This. And this. This. And then this. And then this. And this. This. Okay. So imagine that, right? No top. So this box, what do I need to know for this one? I need to know. Actually, I need to know the. So what we want to do? We want to not just the volume of this. So yeah. So I'm gonna say, I want to know this size, the edge, right? What is x? It has to be x. Yeah. But you also need to know the area of the base, which is you need the width times length. So his length, his width. Okay, so how can you find the width and length? Okay, so let's say okay. I need to label, I need to assign the variable in here. W, okay, so I'm gonna say L, here's L, right? L here, and here's width, okay. So L equal to, small L, equal to the length of the box. So L is the length of the box. And how can you find the length of the box? Just take 16 minus 4x. And also you say W is the width of the box. width equal to 10 minus x. And I think that's maybe I'm gonna have like V is the volume of the box. So now we move to step 3. We say select the quantity that is to be optimized and construct the function. So what is the thing that we optimize? Volume, right? See the sentence here, largest possible volume. So we want to have a function volume. So we say volume equal to length times width times height. Here is x. Right? Length times width times height. Here is x. Okay. And okay, yeah, and I can just say volume V. And step 4, use information to contain in the column to eliminate variable until you have function of only one variable. So that means what? I want to have a function of V that have only one variable. And I know that L is 16 minus X. W is 10 minus X. So I will substitute that to get only one variable, which is X. So L in here is gonna be 16 minus X. And W in here is 10 minus X. And then X. Now, I will, if you want, you can do distribution for this. Otherwise, you may have to do product rule for derivative later. But I say let's do it for distribution here. So 16 times 10. And then 16 times x, gonna be 160, and then minus for 16x, and then what? Minus for 10x, and then plus x squared. That is one. That's one product first. Okay, you should do for this session. You should do step by step. Okay, so now I'm gonna finish with the x outside. I have 160 x and minus 16 x squared and minus 10. Oh wait, I can combine this. So I'm gonna say 26x squared. And then plus with x to power 3. I will move this down. So it's V. So after you do distribution, let me see. There is a small mistake I made in here. I should tell you that we actually had to be, say for W's, it should be not minus on the x is minus 2x, right? See that? And L2, you are minus 2x because you have two p's. So here is the 2x, and here's the change to 2x. And now it should be changed, and I have 160 minus, and here should be 20 plus 6, no, 32 x minus 20 x, and then minus plus 4x squared, and times x out. Okay, now you should have here as 52 better plus with 4x cubed. So now it's look good already, so you can go ahead and move to step 5 here, and taking the derivative of v with respect to x in here, which equal to 160 minus 52 times 2, which is 104x, and then plus with 12x squared. Okay. And now you're gonna set v, set v prime x equals 0. Then you have what? You're gonna copy this now. Equal to 0. And now you will divide both inside by, say, by 12. Let me use my camera to see, to make sure. Let me see. Where is my, oh, okay. So, yeah. And then I say 160 divided by 12. Enter. No, it doesn't work. Say divide by 4, I think better. 104 divided by 4. And then you have 26. Okay, that's work. So now I'm gonna divide it by 4 for both inside. And I have what? So we divide by 4 inside, I have 40 and 26 minus 26 x, and then plus 3x squared equals to 0. So then you will, when we change it to make it look like quadratic form, 3x squared minus 26x, and then plus 40 equal to 0. Maybe I have to move this down and say, okay, A times C can be 3 times 40, 120. This is multiplication. And then B equals to negative 26. Do addition. So two number multiplication is 120 and addition is negative 26. I'm going to say 30 and -4. No, no, it doesn't work. No, it doesn't work. So let's try that one. What about -6 and -20? And you will have, yes, that's correct. Then you will have, because remember that in here a equal to 3, so you cannot use special case. You have to split the middle. So 3x squared minus 6x minus 20x plus 40 equal to 0. And that will give you, you're going to factor out 3x and x minus 2. And then you factor out -20 and for x minus 2 also. Zero. And now you will have factor x minus 2 out, and inside first term will be 2x minus 20 equal to 0. So you will apply zero factor method, and you get x minus 2 equals 0, or 3x minus 20 equals 0. So you will have what? X equal to 2, or x equal to 20 divided by 3. Okay. And those two, and you have to check. Okay, let me see. And because we having choose this value as a critical value, right? So you need to create the number line or the side chart for this case. So you're going to have number line. And for x in this case, what is x? X is the length of the side of the square that is cut from the flat pieces. So you should know that first thing, x has to be greater than 0. And x should never go up to 10, because you go up to 10, then you cut whole that area. So that doesn't make sense. So I will say x from 0 to 10 only. And then this have critical as 2 and 20 over 3. Maybe I'm gonna run this. Okay, and then I have v derivative of x and you will have test. Say before in the interval from 0 to 2, you choose 1. From 2 to 20/3, you choose say what's 20/3? Say 20 divided by 3 equal to 6.6 there. So I choose 5 in here. And then from 20/3 to 10, I gotta choose, say, 7. So for each of the interval, I have to check. I made that check, say, b prime 1, what is it equal to? Say 160 minus 104 times 1 plus 12 times 1 squared. So I'm going to have what? 160 minus 104 plus plus 12 times 1 will be just 12. 68. Okay, so that is greater than 0. So this should be positive. For v degree of 5, I should have, because this is critical value, so I have put 0, 0 here. And I have Vx. I should have Vx in the interval from 0 to 2 is increasing. Okay, so for v degree of 5, I'm going to have what? 160 minus 104 times 5 plus 12 times 5 squared. What is that equal to? So using calculator, 160 and minus 104 times 5 plus 12 times 5 squared. Then I have negative 60. So it's less than 0. Yes. So I know that this will be the maximum. Okay, and I don't even care about after this. Just a time because I'm looking for only the maximum. So I know that at 2, that will make the maximum of the volume. So x equal to will make volume of the box max. Okay, that's the answer. Okay, I think, yeah, we just done this problem. And is there anything else for this? Okay. And that's it. So I'm gonna stop this session here, and I see you next time.